Let's finish off lesson 6. This is a very important lesson with all kinds of important features in it. Unfortunately, some of them are just very shortly described in the slides, but I'll make this very clear. This part is very important. I'll start with slide 10 so I don't miss it. This is not that big a deal, but is a perfect question for a quiz or an exam. Is the difference between abstraction and modularization. Abstraction, looking at the big picture. This is one of the ways of problem solving in computer programming, is you say, well, I have a problem to solve, and at the very first stages you're thinking big picture only. Well, I'll use a web scripting language, or I'll use Java, or I need a database. This is much different than saying I need an if statement, and I need a curly brace here, and I need a semicolon. Abstraction is to ignore the details and just think big picture. Another way of actually solving the problem is to cut it into pieces. Cut it into different classes, different methods, different variables, and looking only at the small details and not at the big picture. That's called modularization. Okay, more important, I'm going to slide 16, 17, 18. 16, 17, 18 extremely important slides that cover too quickly an important topic. Let me show you what's going on here. Every time you talk about an object, a string, or a dog, or a hockey player, or a bank account, what you're really referring to is only the memory address of that object. For example, if I did this, here's my memory in my computer, my RAM. And if I have some code and I say something like this, dog D1 equals new dog. Okay, I can tell by the word new I have a new object. But what's really in here, D1, is an address. For example, 125. And if you go to a memory address or memory cell 125, I would see my dog. And then if I do something like this, dog D2, this might not be what you expect. Dog D2 equals D1. These are only addresses. And dog D2 now holds the same address as D1, 125. The same way that my daughter shares the same address as me for home. There's one home with my daughter lives here, my son lives here, my wife lives here. And if something happens to my house, for example, I paint it blue, is my daughter's house also blue? Of course, there's only one object. If my son's house burns down, my wife's house also burned down. It's only one object, one address. 4 people call it home. That's what's happening here. Dog D1, new dog. Dog D2 equals D1. They get the same address. If I change the dog's name, say to Y, D1's name is Y, therefore D2's name is Y. They're both referring to the same guy. When you're referring to objects only, let me show you an example that it does not apply. Int, okay, this does not apply at all to the basic primitive data types. Int x equals 125. Int y equals x. What's the value of y here? It's 125, and it has nothing at all to do with the previous one anymore. For example, I could say x equals 3. Y is still 125. X changed, y didn't. Y equals 5. Now y changed, x didn't. In other words, if you write these 4 lines of code and you just watch what happens to the values, X is 125, Y is 125, X is 3. At this stage, Y is still 125. Y is 5, and at this stage, X is still 3. If I was going to draw this into memory, and you say X is 125, and then I said Y equals X, for primitive data types, it gets a whole new copy of the data. These are unrelated. Whatever you do to this one does not happen to the other one. This is different than objects. Let me review again what happens with an object. I can have an object like this. Hockey player P1 equals new hockey player. And let's just say the constructor wants a name. Gretzky. And then I can make another hockey player, as many as I like actually. P2 equals P1. How many objects are there? There's one object. Probably has a name Gretzky, and there are two variables holding it. If I was going to draw the memory, I'd see Gretzky in here at some address, let's say 771. If I really look at P1, I could find out it is just an address. Literally, really just an address. And so is P2. And they're the same address. So if I change P2 dot new name, and we change Gretzky's name to Lemieux, well, that goes to the address pointed to by P2, which is 771, changes it to Lemieux. So what happened to P1's name? Well, it's the same object. Of course it's Lemieux too. There's only one object here. A cheap and easy way to figure out how many objects you really have, count how many news you have. Here I have one new. I have one object. P1 and P2 are called an alias of each other, or a pointer. See those arrows I'm drawing? People call those pointers. A C developer would call it a pointer. A reference. A Java developer would call those two references to the same object. So alias, pointer, reference, I like to call them an address because that is literally what they are. They're a memory address. All objects are only memory addresses. You can go to the address and grab the object, but the actual thing up here is not an object. This is the address of the object. So this is not heavily covered in the code, but it is on our quiz. You must remember this, especially if you're going to learn other languages. It's very important. Objects are copied by reference. If you look at the code on slide 17 down here, with person, this are objects. A and B are objects. New, looks like I've got one new person. I do not have a second new person. This is just a second name for Everett there. Whatever A does, of course B will B will reflect it. There is only a single object down here. Just like you can call me Jason, you can call me Mr. Harrison, and if Jason dies, well, Mr. Harrison died. If Mr. Harrison's late for class, then Jason's late for class. It's the same person with different names, different references, different aliases, different pointers, but they're all the same address, and that's what matters. If my address burns down, my son's address burns down. If this doesn't make sense, I'll have to stop this video for time constraints and I'll talk about it again.